All right. Hello, hello, hello. Oh, the Dirty Gull. Thanks for the follow. Appreciate it. Well, welcome to the stream. All right, so the last three streams we've done, we've been benchmarking the cold start time of Lambda functions, and we've been doing this across an array of variables. So we've got this big spreadsheet. This is the nitty gritty of building a talk. We've looked at the init duration as reported by AWS for Node.js functions with varying payload sizes, and we have roughly a linear approximation here, linear curve, which tells me that for every 10 megabytes you're adding, you're going to pay approximately 100 milliseconds in cold start time. Now, we did the same thing for Python, found a very similar result, a little bit more jagged, but generally the trend is the same. Container images are sort of all over the place because there's sort of this the very first cold start penalty you're going to pay, which is okay. It's just something to think about. And then we did the same thing for Bun. We went ahead and looked at what a cold start in the new Bun runtime looks like when you're minimizing cold start time by using container images over something like a Lambda layer or a zip file, which is useful and impactful because container images are cached differently. So we talked about this paper that AWS published about how container images are cached and run on Lambda and how there's this multi-tier cache, and we can kind of see that in the results. Finally, yesterday, or was it Tuesday, we looked at the init duration versus the size of the zip payload. And this was probably the most contentious part. A number of people rightly pointed out that init duration probably doesn't measure the full time, the full time we spent waiting for the contents of the zip file to be transferred to the micro VM sandbox, which is something that an AWS employee, Julian Wood, was gracious enough to talk about in the Twitter mentions and the replies. So we know that has to happen, and I want to do two things today. The first thing I want to do is write a little service that can force cold starts and then measure round trip time, because fundamentally your users don't care about what init duration reported in CloudWatch or Datadog or whatever tool you're using says. They just don't care. They care about their experience. So measuring the round trip time, we're going to actually get a better idea of what that experience is. And also we're going to prove if this holds, because there's a chance that, and again, I don't think this is the case, but we'll find out. There's a chance that this information isn't completely covering what needs to go on for a Lambda sandbox to initialize. So let's kick it off. We need to start I need a new terminal. Hold on. All right, I want to make sure this is big enough for everyone to see and go to the main stream. Great. And I just realized I was talking this whole time instead of showing you the various charts, but that's fine. Okay. It says talks, reinvent projects. Okay, so let's start tmux. Make this big enough for everyone to see it. All right. So I want to start today with the non-loaded functions. These are a series of functions from 0 to 250 megabytes of node modules where we're not loading this code at all. And yesterday we saw that non-loaded code is, basically not impactful on the reported init duration, but I want to see how that impacts our round trip request time, or kind of the total time that a Lambda function takes to run. Sorry, my hood's all goofed up. Okay. For this to work though, we need a tool to benchmark this, and I want to go ahead and start that. What should we call the app? Probably round trip cold starter. Okay. Create a new Lambda function. Oh, 1 second. Okay. As usual, fidget in Vim. Okay, thanks for letting me know that fidget's gonna be rewritten soon. Okay, so as usual, we're gonna remove a bunch of these defaults here and a bunch of the garbage that gets dropped in this file. We're gonna give it an event. We'll give it a post event, and we'll give it a route. We'll call it invoke. Those have to be indented. We'll call this function invoke. And then this is going to need some permissions. And for that to work, we're going to need a couple things. I think it's going to need permissions to invoke any function and then update function configuration. So the strategy we're going to do here is to update a function and then re-invoke it. Yeah, good question. We're automating the collection of round trip request duration and testing with various zip sizes. What does it mean? So we're going to create a Lambda function. Let's go over this real quick before I really jump in. I just don't have as much time as I wanted today. We're going to create a Lambda function. Oopsies, that's not the shape I want. This is going to be an invoker function. And this invoker function will have permissions to do two things. One, it will be able to, it can update function configuration. So for any of the functions we're targeting, I need it to be able to update the environment variable for a function. And doing that will invalidate a running function and will make it so that we have a cold start on the next invocation, which we need. And the second thing it'll do is invoke and report the round trip time for the request. So this is gonna basically go out and talk to all of our various Lambda functions we created in the last few streams, right? So this is like 0MB node, or I think, what is it? Unloaded, what do we call them? I'll look. It's like the 0 megabyte node unloaded dev or whatever. And then it will also do the same thing and talk to another function like a, you know, what do we have? We have like a 200 megabyte or whatever. So the idea is we'll cold start all of them and we'll just see the round trip time for any of these. Oh, it says node. Well, whatever. So that makes sense. Like, I hope that makes sense. The idea is that this little function, this little service, is going to be able to force a cold start on any function we tell it to, or like an array of functions, I think is the goal. And then that function will report back the time it takes to invoke that service. Someone on Twitter pointed out that I forget, it's gonna be down in my notifications. Somebody on Twitter pointed out that that's not a full representation of what like simply making an API gateway call and then measuring the response time wouldn't be super realistic, given that there's like some indeterminate amount of lag within API gateway, which is fine. So we're going to use a couple of things. We're going to do like a direct invoke. So direct invoke is something you can do with the AWS SDK. We'll have to look it up. And when we do that, we'll be able to get the, we'll be able to kind of skip API gateway. I'm assuming you can do the same thing with the Lambda function URL. But I don't know. And we can test that. We can use nodes fetch or, you know, like Python requests and figure that out. Okay, so first let's give our function some permissions. I think it's this. Effect allow, action, and we need two actions. Oops. We need to allow Lambda invoke function, and we need to allow Lambda update function configuration. This is going to be an example of do as I say and not as I do, because I'm going to allow it to invoke anything in my account. I think for me to really, for me to like ship this in any way, I would limit this for sure. And one of the easiest ways to do that would be to put all of these functions that I'm going to invoke in a CloudFormation output somewhere, and either use tags to find them or hardcode them like in an environment variable. Pretty simple to do. And then I could bless this function individually to invoke and update the other functions. But I don't want to waste a bunch of time on stream doing that. So we're gonna give our Lambda function permissions to invoke a function and update function configuration. We're using Node 18, which means we're going to have access to the AWS SDK v3. And we called our function invoke. It's got an event. All right, so there's like a couple of things that have to happen, right? The first thing is we needed to map over all functions in input, and then so we'll create up, what do I want to call this? We need like a Lambda functions, and then we need to pass also okay, so this is just plain JavaScript, which I think will probably upset a few viewers. And maybe it'll make this a lot slower for me. But this function will map over all of a list of Lambda functions, I think by name, maybe ARN, then I'm gonna pass it. And then it will call an invoke function method, like a method that needs to update random environment variable if cold start, and then it also needs to invoke function. Okay, so I think if I still had GitHub Copilot, this would probably be written for me, but that's fine. Okay, let's start with let's start at the top. So a Lambda function with a post request has an event.body. So we can say, what do we want to call it? Function names and cold start? Yeah. Function names cold start, which is a Boolean, equals, again, do as I say, not as I do. We're just going to throw a JSON parse in here. Presumably it'll parse. If it doesn't, it would throw an error. That would be a problem. Okay, and then equals await. Notice that I'm not using any classes. I'm just using pure ES modules, and that's because that's what I've used for so long, and it's the easiest thing just to code up as fast as I possibly can. Function names cold start. Okay, so those are the results, and then we need to, I think, just return it, right? JSON stringify, so we don't care about this. Results, and then cold start. So me, as the author of this, will write like cold start true or cold start false when I make that initial curl request. And then I'll be able to figure out if, I want to even update that function configuration or not. And the idea is to control for variables like network latency, so we can try and kind of get an idea of what like the cold start time, or like a warm start network latency would be, and then we can subtract it out of like cold start, which it's true, it's not completely scientifically accurate, but it's the best we're gonna be able to do. So, which is fine. Okay, so let's get the things we need. We need two things, and I need to look them up. Oh, Drago with a bunch of numbers. Thanks for the follow. Appreciate it. Welcome to the stream. I feel like I can say that now that this is like my 4th or 5th Twitch stream. AWS SDK v3 invoke function. I always have to Google this every single time, even though I know I've got 100 of these examples somewhere. But this is good now. I want to also talk about this for a second. There was a lot of complaining on Twitter and social media, for myself included, about the AWS v3 documentation, which was in place after they were like, we're going to deprecate v2. It's gone. It's dead. We don't care anymore. And we're moving to v3, and there were no examples. Oh, thanks for the raid, Drago. Welcome for everyone who's here. Folks joining us from the other stream. We're building a Lambda function that can update other Lambda functions and then invoke them. And the idea is to measure the round trip cold start time for Lambda functions across varying payload sizes. And by payload, I mean like the contents of the zip directory that you upload to Lambda. Hey, yeah, thanks for dropping by. So we're writing a Lambda function. We're about to import the libraries we need. And I'm just going to, I'm not going to use ES modules. Lambda client invoke command. Okay. Okay, so we need those things here. Oh, we also need the other one. The other thing is the naming is better. So I don't love the fact that this is like a completely procedurally generated. So they are not procedurally generated. It's a generated SDK based on a bunch of JSON using I think it's called Smithy, tool called Smithy. But at least the naming conventions are good. Yeah, I think this is it. And this is already deprecated, but there is good stuff here. Here's the right one. I'm sorry for people I was talking to earlier that this is correct for the V3 SDK, and we need to update function configuration. Perfect. Okay. So the nice thing is once you know, like I knew the policy, right? So let's go back and check this out. I knew what the policy was, and it's consistent now, right? Like the policies match the modules, which is great. It's like really helpful. Yeah, and of course my editor isn't even going to help here. We're using I don't have types, and we're using just a totally plain editor. I'm surrounded by Italians. How does it feel? Feels great. Appreciate it. That's my first raid, man. Thank you. Cool. Okay, so we've got we've got all the various SDK bits we need here. We need to just initialize a new Lambda client. I don't think I need to pass anything. Okay, and then we need another thing that's just literally this method is just going to be called invoke function. It's going to take a function name. What do we want to call it? Lambda function, maybe? Yeah. I've worked on I've done a lot of these before, so it looks like I'm flying. I have other examples that I've done before. And I just don't have as much time today as I needed to because we didn't have any coffee this morning. Okay, first things first. If cold start is true, now we need to, update function config to trigger cold start. Okay, so then we can do await lambda client.send, and then we can, does it need a bracket? No, it needs the command. New update function configuration command. There we go. See, now this is a little easier. And this needs a function name, so it's going to get the Lambda function. And then it needs environment. Yeah. I've got one of these pulled up. Hold on. Update function configuration command. Yeah. Okay. So I'm right. This also, if you're familiar with the serverless framework or you've looked at a bunch of this like CloudFormation or CDK before, all of these are going to just be eerily familiar to you after a little bit of time. So it's like pretty, I know it's by function name. I'm surprised it's not by ARN. Maybe there's an optional one or you just parse it down. But regardless, because your Lambda client is configured in a region, in my case, it's US East 1, so I don't have to actually pass it, which is great. It's super easy. I'm able to just give it a function name and it knows how to find that function name, which makes it pretty convenient. So, all right. How long have you learned Python? This isn't, this is JavaScript, not Python. And how long have I been writing JavaScript? The answer is far too long. All right, 1 second here. I gotta help my wife out. All right, sorry about that. I am back. Let me catch up with chat. This is great because I thought it was, and also worried a bunch of stuff I don't know. Yeah, no, it's just JavaScript. It's just regular, plain Node.js, no types, no libraries. I wouldn't say I prefer that for like real projects. For real big projects, I definitely prefer TypeScript if I'm writing JavaScript. But I just haven't, for this one, it's plumbing a bunch of SDK calls together that I know very, very well. So it's just pretty easy for me to sort of skip the types and skip all the other packaging and bundling stuff. And then I don't have to worry about, source maps. So I don't have to worry about confusing stack traces when I make a mistake here, because I will. What is it? It's environment and variables. And okay, the other thing that annoys me is that, all of these are not the right, like they're completely not cased in the way you would do it for JavaScript, right? In this case, they're all title case. JavaScript, we traditionally, like any variable in a map, we would have it'd be like lowercase and then our camel case. So it'd be like lowercase f function name, like this, the way we do it here. So that's an annoying thing about Smithy. Yeah, I do think that I miss manually written code. I would love to see I totally understand the problem they're solving. They have to have a consistent SDK for every single language, but it feels like they did so much work to make the publishing and the updating and the service teams be able to publish software, and then they just stopped at putting a ton of work into consistent conventional naming along with the programming languages they're supporting. I'm sorry if people feel that that's an unfair category or miscategorization, but that's definitely how I feel. Okay. I need a random bit of data. Actually, I have this already somewhere. Hold on one second. Let me grab. Here we go. Okay, so let's just, this is just going to create like a random little string. And actually here, I'll just show everyone. Can everyone see? Yeah, okay. So if we it's just going to create a random couple characters, that will allow us to update a environment variable and be pretty confident that it's not going to be the same. So we'll create a new Lambda function configuration, which will then update the sandbox. So you can do this yourself if you just go into the Lambda console and go to the environment variables and then just delete an environment variable, or better yet, like update one or create a new one and change the value. That's all we're doing. Okay, so that sets a cold start. So that should be good. Now we have to, mark start time, invoke function, mark end time, do math, return. Awesome, right? So const start equals date.now. Date.now is going to give me a timestamp in millis. Nanos might be better, but millis should be fine. And then, okay, await lambda client.send, and then new invoke command. And then there's a few parameters for the invoke command. Oopsies. And we want to get a response for this. So let's figure this out. Lambda client, invoke command. It returns. Yes, this is great. This is all I need. Like, this is all I ever needed. All I ever needed for my documentation was, what are the inputs? What are the outputs? What's required? What's optional? And what are the values? So we have to pass a function name, just like we'd expect. Invocation type has 3 options: dry run, which doesn't do anything, event, and request response. This is not super clear. So request response is a synchronous request and response. I guess that's pretty clear. Event is weirder. It's async. So you give it a bit of information, and then it will just take that and actually enqueue it and then run the Lambda function as soon as it can, but it returns to you immediately, which is not what we want to do, because we want to measure the end-to-end request response of a Lambda function. So just giving it an event would be like an async call, way too fast. And it's going to respond with a payload, and I think it literally responds with a blob. So I've done this too. Let me look. Okay, so it responds. Okay, so it responds with like an array of bytes, and then we can parse that into a buffer and then a string and then JSON parse it, which should be good. Invoke command send. Okay, so then we have the end time. Actually, we should bring this up here. I'm also live on Twitch and LinkedIn, or on YouTube and LinkedIn. I want to make sure I'm not getting any comments or feedback there. No, just Twitch chatters today. That's great. And yeah, if you're just joining us, !reinvent, and you can get all the information you need about the talk I'm giving at reInvent, what this whole project has been for these last few weeks. The whole reason I even started streaming or doing any of this was to force myself to start writing this talk as early as I could, which is good because it's taken me a lot longer than I thought it would in my head. All right. Invoke command, we need a function name, and it's Lambda function. I think that's all we need. Oh no, duh. It's the event type. Invocation type request response. Okay. Okay. So once that's done, we can record another date stamp. So now we've got the start, we await the call, and we have the response. Of course, there's overhead here, there's context switching, there's a bunch of other stuff. That's totally normal. That's totally fine. Let's make sure we give this function at least one running vCPU core. Memory size 1782. So at 1782, you're going to get one unthrottled vCPU at runtime, which I want to make sure we have so we don't have like a interrupt between this request and then, or like this response and then when we end the date. It's probably not a guarantee since it's a shared resource, shared CPU, but that is totally fine. And then yeah, definitely let me know in the chat or in the comments on YouTube or Twitch or LinkedIn if there are the audio is too loud or messed up. I'm still learning how to do all this. Okay, mark end time, do math. This isn't math, this is just subtraction. we know how to do that. Oh, we need to get the payload. Yeah, what's it called? Payload. Yeah. So that's a response. So I think all I care about, I don't care about the status code. I don't care about if there's a function error. I mean, I do care if there's a function error, but I doubt there will be. Payload. Yeah, so let's start with just this, because I think what I want to do, in all of these functions that I created, I've been returning the timestamp. Oh, okay. Thanks, Drago. I appreciate that. Chime in and let me know that the audio sounds okay. So these functions that I've created, I've been returning like a timestamp of when the handler ran, and I want to use that to figure out sort of, we have 3 times, right? We have T1, so like request is made, request made, and then we get this response back, right? But in this handler, I want to find out too, like when did the handler run? And then finally 3, oopsies. So then I want to know when the response arrived. So I think that's what we can do. I think we'll start with 1 and 3 because I can do that all in one handler function, and we'll go from there. What is the result of this call? Okay, so const round trip time equals end minus start. That sounds good. And then we just need to return like the function name. Oopsies. Lambda function. We'll call it function name. I should be better about my variables. Okay. That looks good for now. We have this conditional, which is sweet. Now we need to, okay, oh yeah, duh, I almost missed this. The Misco, thanks for the follow. Thanks for dropping by, appreciate it. Regalias, why do you need the payload? So I'm making all of these Lambda functions are going to return a timestamp when I invoke them. And oh, thanks, Drago. Thanks for sticking around, and thanks for the raid. They're going to return a timestamp when they are invoked. And I'm going to use that as like a third data point, because I want to see when the request was made, the handler that received the request, what timestamp in millis did that run, and then when was the response. I should call out here, this is a large distributed system, and clock skew is absolutely a thing. I can't control for it. I'm not going to try to. In theory, I could reach out and talk to like a time server, but I don't think that that would cause like another round trip latency request in there, and I don't want to do anything over the public internet. And also, AWS has a ton of really good blog posts about their own time sync service, which is incredibly good as far as I can tell. So I've never really had a clock skew problem in Lambda. I've had what I thought was a clock skew problem in Lambda, but it turned out to be them warming up our Lambda function invocations for us. If you haven't read about this, this is called proactive initialization. This started with a bug, or what I thought was a bug, an unexpected time gap between function initialization and invocation. And it turns out they're just actually warming them up in some cases, not necessarily intentionally because they want to keep them warm. However, warming them up because they need to run a large-scale distributed system. And to do that, you have to load balance. And to load balance, you have to make certain decisions. Okay. All right, let's go back to the function. Oh, I forget how this works. So it's, is it return await or, yeah, no, just return. I don't think you need return await. I think there's an implicit await. Promise.all, and now we need to map over the functions, lambda functions.map, and we need a anonymous function here. Function name. Invoke, what do we call them? Invoke function, lambda, or no, function name. This is hard to see, I'm sorry, I know that. And then cold start. So we're mapping over our list of Lambda functions that I'm going to pass in the request. That yields a function name in an anonymous function. So then I can map over my invoke function method and also pass the cold start variable. And I believe that all async functions return an awaited promise implicitly. We'll find out. This will be pretty easy to find out and see if we're wrong. I think a couple more people have clicked on this stream, so welcome. My name's AJ. I'm a AWS hero and a staff engineer at Datadog. I work on serverless stuff. I've been working on serverless technologies for a long time, since like 2017 or so, probably full time. We're working on a talk that I'll be giving at reInvent, which is AWS's annual conference in Las Vegas every fall. It's in November. The talk is all about AWS Lambda Cold Starts. What I found, and the reason I'm doing this talk, is that a number of people have no idea about AWS serverless technologies at all. They've never used Lambda. They've only used EC2, or maybe they've used EKS or Fargate. And they don't even know like what Lambda is or how to use it or what you'd use it for, but they know about cold starts. So sort of the reputation precedes it, and I want to just provide clarity for that so people understand what you can and can't do about them, how they impact your runtime, and just a number of other edge cases and kind of dispel the FUD around them. So that's what we're doing. We're building a interesting service, a Lambda function that can update and invoke other Lambda functions. If we want to get crazy, this function could even change the code, and we may do that. Let me look at my sample function that I've done before. I think this is pretty good. Let's find out. Okay. Export AWS profile equals personal. Whoopsies. Oh, invalid. What did I do? What? It has path and... Oh, not route. That's better. Oh. Oh no, review in progress. Nuke the stack, start it again. And yeah, while we're doing this, if you want to chime in, if you've got questions about your serverless applications, if you've got questions about your anything you're doing inside of AWS, feel free to drop them in the chat. There's a lot of things here that are implicit, and one of the things I talk a lot about, but I should probably clear up, is how you should use use the AWS console if you're new. So let's log into my 1Pass and then search for AWS personal. Okay. Yep. Open and fill. All right. So I am logging in to my AWS account as an IAM user. I am not logging in as root account. For day-to-day operations use of your AWS account, you should always have an IAM user and not a root account. And the reason is that the root account can control billing. It can do a number of other things that you don't necessarily want to be able to do all the time. And when you're using an over-provisioned account, you're more likely to have an issue with like credentials leaking and then, you know, your credit card being changed or things being turned off. And you can actually like limit a lot of your permissions and still do your job using something like this. So I separate my console users into CLI users and console users. So it's just me. I don't have anyone else here. And I have two users. I have the personal who's logging in, which is me that I just used. Then I also have an access key that I'm using to deploy. And then I can actually limit what either of these can do, which makes it just easier to do something on stream. It makes it easier to ensure that like any conflicting, I won't have a case where a service account that can deploy something can also like update my billing account or like spin up a bunch of new resources or something. So I can kind of segregate and separate in that way, which is just good for safety. Okay, we've got this function. We need to curl-d, and then we need string. We said what function? And this should be an array. What do we call these functions? Lambda. I have a pattern for them. I did a good job. Unloaded. Okay, unloaded. So unloaded 0 MB dev hello should be the one. It needs an accept header, right? -h accept application JSON. I think it does. Has it got to be in a string? I forget how this works. Yeah. -h, and then it needs content type. Thank you. I'm so glad I referenced this. I use roles instead of users, less risk. Totally, absolutely. Like roles are even better. I have a role and a user. You can assume a role, and we can probably do that on stream at some point. It only gives you temporary credentials. In my day jobs, we always use like SSO. So you log in through your single sign-on provider like Google or Okta or Microsoft or whatever, and you temporarily authorize yourself to access the console for a little bit. I should probably do that here, but this is probably enough for what I'm doing. Type app. Internal server error. Awesome. We have a result. Let's find out let's go to our old friend CloudWatch. Barrel roll. Hey, thanks for joining the chat. Yeah, definitely. I mean, the roles are superior. They're just a little bit more complicated to set up and a little bit more of an annoyance. Okay, I've got 30 minutes left before I have to jump on a call. I'm jumping on a call with Jan, the AWS serverless hero, and you've known him, you've seen him. I actually don't know how to pronounce his last name. But we're gonna talk about serverless for his podcast, which will be fun. What do we call it? Cold start dev invoke. Resource not found exception. Unloaded 0 MB dev hello. Did I get that function name wrong? Oh, service. No, that's just the, no. Oh, thanks. Good call, Doug. I missed the node. This is why Twitch is so helpful, because I could have probably sat there for like 30 minutes trying to figure that out. But I've got Doug here who's just helped me out. Node. Hey, we got a result. Check that out. Round trip invoke milliseconds, 412. 412 milliseconds. So why am I doing this in Node.js? And I'm sorry, why am I doing this in a Lambda function and not from my account? Because I could just as easily run this on my laptop. And the answer is, I have good internet here in Boston. However, AWS's data centers and their availability zones, which are AZ is a physical data center, are connected via these like giant network fiber backends between all three of them. They're only, I think they're on different floodplains, but I think they're still geographically quite close. So Lambda function, when you invoke it, can run in any of the availability zones in that region. And my theory is just that the closer, the better here, right? Like the physically the closer these functions are, the better. It wouldn't surprise me given the low throughput if they just are all being spun up in one AZ, but I can't speculate. Because we're doing round trip time, we have to account for the fact that in some of these requests, I might be invoking a function in my own building physically, like in the availability zone, or in others, I may be crossing the AZs. Again, it's still quite fast, but I want to control for that by just collecting a ton of data. And that's part of why we're automating this today. Okay, great. Let's, there, that's better. Okay, that's an awesome result. Two things have to happen. The first, let's log our output. I'm 99% sure. Const payload. So we're gonna grab the response, which they also call payload, from the Lambda invoke. But this is a blob value, which tells me that the response is gonna be a, it could be a base64. No, it's not base64 encoded string. But it's probably the raw bytes of the response. So then const parse response equals buffer dot from payload dot toString UTF-8. And then I think that'll still be, I think we have to string response. And then I think we need to parse it. Oopsies. Okay, let's deploy this. And let's figure out what that response is, because all of these functions should be responding already with the time that the handler ran. And if not, we can edit it. So like, let's just take a look at the code. Unloaded 200 megabyte node dev hello. Oh yeah, it's too large. Of course it's too loud, too large. What about 0? Unloaded 0 should be fine. Feedback for Richard Boyd if he's in chat, which he would be screaming at me if he was in chat. It would be great if the in-browser editor knows when something I'm editing. Yeah, okay, perfect. And I want this editor to know when my handler file, like this JavaScript file, is small enough to edit and not like my node modules. I know it's a hard problem, but you're smart people. You can figure that out. So yeah, so this is going to return a JSON body with a handler.ts. So let's parse that. As soon as this is done, is this done? Okay. Oopsies, no. Curl. Perfect, okay. Come on. I was right. I mean, I knew ahead of time. I knew the answer to the test. So we actually have to parse the body as well, because that's also a JSON string. I think it should be body parse response.body. So it should be, we should be able to just destructure this. Handler TS. Okay, so now we know const time to handler equals end, or what is it? End minus, no. Handler TS minus start, right? Because then that should tell us the difference. What do we want to call this variable? Yeah, I think request to handler MS. Okay. Deploy that. See what we get. It's not, and again, it's not going to surprise me if we have a round trip time that is less than the time to handler, because I think that the response time is going to be really, really, really fast, because the response time should be really fast because the TCP connections are already made, and that network connection's already been established. The console may be pulling the entire zip client side. Yeah, barrel roll, you're absolutely right. Like there's a bunch of reasons why, but the zip, as far as I know, and I was told on Twitter by someone who works at AWS yesterday, that after you upload your function as a zip file, like that's just for transport to AWS. Once it's there, they unzip it, and that's how those dependencies are then copied into Lambda when the function runs. So I shouldn't expect, like, it shouldn't surprise, I shouldn't expect that they have no way to figure out what's in that zip file, and they're not like just unzipping it client side. Like they should have a manifest list of bytes, and they know the handler. They know exactly what function, I have to set the handler here. So they know what function is where. And yeah, Webpacking or ES build would totally change all the nuance here, but this is pretty easy. Okay. Where were we? We were in CloudWatch. Well, let's just curl it. Okay, this is good. So on a cold start, 295 milliseconds until the handler that I called responded, and then 324 until it all the way returned to my service. So now we have to just give it more functions. Unloaded, okay. Unloaded 50 MB node dev hello. Unloaded 100 MB node dev hello. I missed the array end. Shoot. Oh no, no. That's, yeah, of course it's a, I'd write down those values somewhere. Oh, I don't need to write them down because I'm going to regenerate them a lot. And then we'll actually probably stick them in DynamoDB. DynamoDB, use it instead of pen and paper. If this works the first time, I'll be so ecstatic. No way. Did everyone see that? I'm glad this is streaming live and people saw that worked. That is awesome. Unreal. I typed all of those function names correctly the first time. All right. Round trip time for 0 megabyte Lambda function, 313 milliseconds. 50 megabytes, 904 milliseconds. 100 megabytes, 567 milliseconds. 150 megabyte, 1,451 milliseconds. 200, 812, 250, 581. So there's a lot of variance in these numbers, which is good. A lot of variance. So on the stream on Tuesday, we came up with this number for what AWS Lambda reports as the init duration. So it says when you're initializing your function, the size of the size of just data in the zip file doesn't impact init duration until you load those files. So in Node, we're talking about like an import or require. In Python, that'd be an import. It's different in Go and Rust because you're going to generate one giant binary blob, and you'll have to, like, the binary itself will load all of those bytes unless you have dynamic linking or you have some other strategies to do like lazy loading. But we sort of found this, and I think a lot of people were surprised. I think this data, and we'll rerun this. I'll probably run this like hourly and export this data into Dynamo and then fetch it at the end of the day. But we see, the difference between 0 megabytes and 250 megabytes is 200 milliseconds. And in some cases, the smaller functions took much longer than the bigger functions, right? Like the 250 megabyte was done in 581 milliseconds, and the 50 took 904. And a lot of that could be network jitter. It could just be those individual nodes, those individual Lambda workers are all going to have varying levels of load and throughput and various amounts of, other things that are happening whenever this request is made. So there's some variance. And what I want to be able to prove is that, or what I shouldn't say, what I want to be able to prove is whatever the data says. But what I believe is the case is that the biggest impact that users can have is going to be on the code you submit. The biggest thing you can change. Okay, bunch of questions in chat. Let's go. Does AWS store the executable instead of the source code generated by compile? Yeah, you don't push the source code at all to AWS for a zip function, or for a Lambda function, zip or Docker or otherwise. It's like the compiled binary is what's getting executed. They have code build. You can put source code into AWS if you'd like, but no, you don't. You're sending them a binary and they execute it. Doug asks, how much RAM do they have? Each of these Lambda functions that we're calling has 1024 1 gig of RAM. We can adjust that. We can change all of these, and we will, and that's part of the talk. But in this specific case, they all have 1 gigabyte of RAM. The calling function has 1.7 gigabytes of RAM because, as far as we know, that gives you a full vCPU, and I'll show you the docs for that. Is it 1782? Maybe it's 1769. There's a doc that they have for this, and I should really make it just a response. Where is this? Yeah, at 1769, the function is the equivalent of 1 vCPU. So, okay, sorry, I was doing 182, it's 1769. But it shouldn't matter because I don't think I get more vCPU for that extra, whatever, a few megabytes. Yeah, so it's here it is. That set of vCPU is just a hyperthread, right? So technically you need 2x that to grab a full core to yourself. I've heard that. I don't feel confident in that. So I don't want to speak to that on stream. I know you and I have talked about that. Should we just find out? Should we see if these numbers change? We should give it let's just give it 10 gigs. What the hell? I know Fidget's being rewritten. Fine, give it 10 gigs. Give it all the cores. Most of them will be idle. Okay. So we have uncapped vCPU. And we have pretty similar numbers, right? Some of them take a little bit longer, up to like 1.1 second. And this is just for invoking. So that each of these, the functions we're invoking all have fractions of vCPU, but they do nothing. They just respond with the current timestamp. I don't think increasing those resources will change this whatsoever. But the calling function, where we want to make sure we don't context switch between when we call that response and when it comes back. And maybe doing this in a promise.all isn't ideal. No, it shouldn't matter. It shouldn't matter. But we can probably tweak this. We can probably run each one individually instead of promise.all if we think that's an issue. Now though, one thing we did that we haven't used yet is a cold start. I'm gonna just, okay. What do we do this? We called this the round trip cold starter. Oh, okay. So I don't want to keep getting that response from NeoVim. I don't know why it's complaining, but I'll figure it out. So one thing we haven't done is we've been just saying cold start true, cold start true, cold start true. And when we do that, it's going to update that function configuration. And I want to see what this is like when we set cold start false. Because now we're going to have, in theory, we have a warm start. And we should see the difference. Still 500 milliseconds on a warm. No, that can't be right. It's got to be updating the function configuration. Oh no, there. Okay. Uh-oh, -11. So there's a little clock skew there. Little clock skew coming through. Can you show your updated configuration code? Sure. Here it is. We are updating we are just setting a variable called cold start to a random substring of 6 characters. So that's all it's doing. And we can see that take effect, right? Like we can look. Isn't it technically async and you have to do the $wait for? I don't know what you're talking for the invoke. You have to do, I think it's just request response does that, because I'm getting the data back. I'm getting the response from the handler. I'm returning a value. So if there wasn't anything in this body, it would have an error. So I think we are waiting for it. Otherwise this would be either, yeah, totally, Doug. You're totally right. There's okay. So what Doug's saying, and we can talk about this. What Doug is saying is that in between updating a function configuration and directly invoking it, there's like doing it the way I'm doing it, which is update and then invoke immediately, is just not technically correct, because that update function configuration can take a couple of seconds. So while it's updating, I might be hitting the old function, and that's totally true. When I automate this, I need to handle it. I was just gonna put like a wait for 200, like a sleep for 200 milliseconds, and call it good. But maybe that won't be enough if there's like a wait for. But you can I'm just rerunning it, and that's fine, and that's what I can do on stream. The SDK has it using promise.all. Yeah, we can. Lambda client.wait for function. Yeah, we can do a wait for. Barrel roll, use promise.all, more likely have multiple up connections versus reusing the same one. Yeah, totally. But in this case, I mean, yeah, there's a chance that we're reusing one connection and setting up another one, so we're changing the cold start time. I think the way to do that then is to not use promise.all, right? Like just individually run each one. I think in that case, your first invoke is probably going to set up the connection, and maybe there's a penalty there. But I would have expected, if that were the case, I would expect that first cold start to have a much longer impact, and I'm just not seeing it, right? Like 24 milliseconds, 18, 17, maybe 4 milliseconds of connection overhead. I mean, we can run this 1,000 times, Like if the case was because we start at the very first function and then we set up a connection and then it's maybe reused in the previous ones, Yeah, exactly. Like they're probably all new connections because it's being run in parallel. You have 1,024 file descriptors. Yeah, my orchestrator function isn't cold starting, then it's reusing. Exactly. Keep alive for the AWS SDK is set true to default. So those TCP connections can be reused even across serial invocations, which is great. Good job on AWS for doing that as like a performance improvement overall. Oh, I can't believe I used the wrong apostrophe in my Twitter Twitter announcement. I did users with an apostrophe. I was so frazzled this morning because I was late and I was out of coffee. So I had to run to the coffee shop and I was worried I wasn't gonna have time to do all this. I deeply apologize for this. If I offended anyone, I'm really sorry. This is a great result. This is really cool. It's not definitive. I'm not going to tweet it as definitive. I'll share this as preliminary, but like if we look at all the cold starts. So, okay, this is exactly an example. I just changed the cold start to true and I didn't wait for that configuration to take place. So it hit all warm functions, which Doug, totally right. When I do this, when I automate this, I need to control for that fact, but I'm not automating it yet. I'm not gonna have time. But that's a cold start. Look at those. And I also think I feel good about this result because the 0 megabyte function is consistently a little bit faster than everything else. But what's interesting to me is that these others seem to be clustered. Like it seems to be bimodal. And there's a bunch of reasons I can think for that. The biggest reason, the number one reason is that dependencies have to be copied into the sandbox. And when you have none, even if you're not importing them, they don't. So it's just more stuff. Curious on the 150 megabyte. Yeah, let's take a look. Let's go find out. So unloaded 150. Oh, we can also turn on X-ray. Should we turn on X-ray quick and look? Regalia, how long does the cache last once it trigger a function? No idea. Not published, not public, unclear. I'm not going to try to make, sweeping statements. What I do want to do is just show the data. I obviously have thoughts. Okay, good. So that's all working. Do we have X-ray turned on in this function? Okay, let's turn X-ray on, but let's get the logs. +1 X-ray. I've really avoided X-ray. I work for a product that can ingest X-ray. I work on that product. That's a service that my team owns. But then I also work on, Datadog's tracers. So I just didn't want to. Fun fact, AWS can tear down your function while it's still being, quote, deployed, and an invoke will simply fail and you need to retry it. That doesn't surprise me. So it's saying the init duration was 177.69 milliseconds for this function that took 1,100 milliseconds to respond. Init duration has been very consistently reported as like 180, 170 milliseconds. So we did the same thing with just 0 megabytes was 182 and so on and so forth. So it's very consistent in this like 150 to 200 millisecond range. I don't think there's any point in looking for smaller variances in round trip time because there's always going to be a huge amount of jitter there. Like definitely. But init duration, when it's tracking, it does track how long the like runtime node takes, the process takes to start, and it also tracks how long your code, like the static initialization of your code. So is it fair to say 90% of that cold start was on AWS? I think in this case, yes, but keep in mind we're loading 0 code. So that's just like, that's not even representative of what a user would do. It is just something I'm hacking on. We have to rerun all these benchmarks with actual functions that load actual dependencies. And in that case, you're going to see far, far, far more of that pendulum go. I wouldn't really say that like this cold start is on AWS. I just would say that what I'm trying to do now is establish a floor. Like what's a reasonable expectation for a base Lambda function to execute and return within the same AWS region. Since we can't control which availability zone our functions deployed into, region is like the closest level of granularity we can get. So I call this a great result. Pretty happy about that. So next steps. I would, yeah. Doug says I would like to see an SLO for this type of thing. Yes, I would also love to see an SLO for how long it takes AWS Lambda to invoke your function, like for sure. Or at least like the SLO for how long it will take them to run a request. If anyone in the Lambda team is watching the stream, I'm sure that me saying that makes you sweaty, but that would be great. Because yeah, there's clearly a lot of variance here. Even amongst like repeated comparisons of 0 megabyte node. Let's do another one. Yeah, so that's 293. The other one was 313. I mean, there's like 20 milliseconds there. That's not bad. Sorry, I accidentally quit out. So 293 round trip, 289 until that handler was hit. And the one before that was 314 and 318, which is pretty close variance, actually. I guess I take it back. That's pretty close. I think once you start adding your own code, it's going to be very different, because my assumption is that if I were designing AWS Lambda, I would either have enough of a cache on each worker to store like the base runtime for all of the runtimes, or I would separate my workers into the runtimes that customers would deploy their code into, and then just have that the base Node or Python or whatever interpreter and dependencies already pre-cached on all of those worker machines, or even better yet, on the micro VMs. So David Nasi on Twitter mentioned that they pre-pool Firecracker VMs, so they're already initialized, and effectively all you have to do is copy your code into the VM and then initialize the process and start Node or start Python. And then you'd get to see and then we get to kind of see like a more performant system, or I'm sure like that's how they got the performance to the way it is, because even this, like a round trip time, is still pretty impressive. Maybe AWS could any AWS cold start over 500 milliseconds is applied as a credit against your execution duration. I mean, init is already free for managed runtimes, so I think that's probably pretty good. All right, folks, I really appreciate everybody sticking around. Let's see if we can find someone to raid, because I have to go. I'm going to go raid AWS's channel. Oh, we can't raid AWS? That's ridiculous. Nobody else I follow is streaming right now. I guess that's probably typical. All right, I got to run. Folks, I really appreciate everyone sticking around, hanging out. I will write some of this up and share it. And again, if you're going to be at reInvent, go over to the session catalog. The schedule's now available. I'll be in Caesar's Forum on Wednesday at 1 p.m. in room 214. You can go to the attendee portal, hit the agenda, search for COM305, and favorite the talk. That's all I got. I appreciate it. I'm going to go record a podcast. Take care, folks. Have a good one.